In this video, we'll learn about the vertex and shape of a parabola. What we're really talking about are functions that look like ax squared plus bx plus c. We often call these quadratic functions. So what does the graph of a function like that look like? Well, if we start picking some random values for a, b, and c, the shape that we get always looks generally the same. It always looks like sort of a U-shaped curve. Sometimes it's skinnier, sometimes the U is wider, and the U is even upside down. But it's always got that distinctive U shape, and that shape is what we call a parabola. So that's sort of a strange word, but that's the word that we use for this type of curve. So how do we know which kind of parabola we have? Is it wide, is it skinny, is it right side up, is it upside down? Well, a lot of the shape of the curve really depends on this value of a. And we call this the leading coefficient. It's the first coefficient of this formula, although it would still be the coefficient of x squared even if we wrote the terms in a different order. So sometimes we'll try to trip you up and write the equation in a different form, but it's always the number that's sitting in front of the x squared. That's the leading coefficient, the a. So what we see is that the bigger a is, the skinnier the parabola is. If you rewind the video and go back and look at the examples that we saw, the larger values of a made skinnier parabolas. And the closer to 0 our value of a is, the wider the parabola is going to be. So if a is a very small number, then it's going to be a very wide parabola. And if a is a negative number, then the parabola is upside down. Now the b and c values determine whether the parabola is sort of to the left or to the right or up or down, and that relationship is a little bit more complicated, but the a relationship in terms of the general shape of the curve is very clear. There's one more thing about the shape of a parabola that we want to talk about, and that's what we call the vertex. Now, since all of our parabolas have this U shape, that means all of them have a special point right around here where the parabola stops going, in this case, stops going up and starts going back down. If it were a right-side-up parabola, it would be the point where the parabola stops going down and starts going up. But it's the turnaround point. So you want to think of this in this sort of informal way as this turnaround. That's our kind of informal way of thinking about it. But the official word that we use is vertex. So the vertex of a parabola is that point where the parabola turns around. So how do we find that? We're going to see when we do some applications that it's very useful to know where that point is. Well, it turns out that the x-coordinate of the vertex is at x equals negative b over 2a, where again a and b and c are the coefficients of this quadratic function. So let's find out where the vertex is for this quadratic function that we're looking at. So where is this point right here? Well, we know what a, b, and c are. A is negative 2, b is 8, and we don't really need to know what c is, but we do, so just to make sure, c is 5. So the vertex is going to be at x equals negative b over 2a, which in this case is going to be negative 8 divided by 2 times negative 2. That's negative 8 divided by negative 4, which works out to be positive 2. So that tells me that the x-coordinate of this mysterious vertex point is 2. So the vertex is 2 comma something. Well, what's the something? Well, since we know what x is now, we can take that x and plug it back into our original formula, and that'll tell us what the y equals. So in this case, y equals negative 2 times x squared, my x is 2, plus 8 times x, so 8 times 2, plus 5. And when we work all that out, that works out to be 13. So that means that my vertex is at 2 comma 13.